Hello everyone, how are you? Welcome back to the channel. Yesterday, in the previous video, I introduced quadratic equations, and we said we are looking at a crash course called 9709 CIE Pure Mathematics for the AS level Cambridge syllabus, and you are on Learn Math with Dennis, and I'm Dennis, your tutor. So let's continue to part 2. Here, yesterday we were looking at factorization, and we said that during factorization there are two terms basically called the one in the middle is called the sum, and the one at the extreme right is called the product. And we said that a quadratic equation is an equation in the form ax squared plus bx plus c. The number in this position is always called the sum, and the number in this one in this position is called the product. We also learned how to manipulate quadratic equations and solving them using factorization. For that, you could go to the previous video and watch it. And today we are going to look at another method of solving quadratics, and it is called completing squares. Okay, so we're going to look at completing squares and see how we can use completing squares to solve different aspects of quadratics. Okay, so when we are completing squares, as I've said, it is another method of solving quadratics, and quadratics are equations with power 2. We've already talked about that. Okay, so basically completing squares aims at this. You are writing the equation in the form this. I believe at IGCSE level you've encountered questions that are asking you to write a quadratic equation in this form. So sometimes they will not tell you directly that solve the quadratic equation using completing squares. Sometimes they'll say write this equation in the form x plus a into parentheses squared plus b. So this is completing squares, and we are going to look at it in detail so you can see how this is useful. This is also applied when we are asked to calculate or to find turning points of a certain curve. We use completing squares, as we shall see in the coming video. Okay, so let's focus on completing squares. Our learning objectives is by the end of this lesson you should be able to use completing squares to solve different quadratics. Okay, yeah, that is the main learning objective today. So let's start. So when you look at the first one, this is the most basic quadratic. Okay, most basic quadratic. And if you see this type of quadratic, what does it mean? It means that this quadratic, remember quadratics are curves. This is a curve. Any equation that has a power is not a straight line. So basically this is a curve, but the curve is on the x-axis, and it turns, we call it the turning point. We shall talk more about turning point in the coming videos, and the turning point is 0, 0. Okay, so basically if you see such an equation, these are the key features. It is on the x-axis and the turning point 0, 0. Now, if you write the quadratic equation and you write it in this form, okay, from this form you can make a conclusion about the turning point of a particular curve. How? If you have this, okay, this implies that the x-coordinate of the turning point is negative a. If it is a plus, then this is negative a, and if this is a plus, then you maintain it as a plus. So basically, if you write a quadratic in this form, you can pick out the turning points. Am I making sense? I hope I am. If you have any questions, just comment in the comment section Don't forget to like, don't forget to follow and subscribe, okay, on this channel. So we are going to see how we can complete equations and complete squares and solve equations, and also at the end we can also talk about briefly how to get turning points. So we have an equation here, y equals x squared plus 6x, and I'm going to teach you how to complete the square and how to get the turning points. All right. So if we have this y equals x squared plus 6x, note that the coefficient of x is 6, and also remember the general equation, the general form of a quadratic, bx plus c. So the b part, the coefficient of x is 6. So when you are completing square, you start by halving. Halving means you halve the coefficient of x. So if we halve the coefficient of x, it's 6 in this case, we get 3. So after halving, you square it. All right. So now this is what we have. We have x squared plus 6 out of 2, but we square the result. Does that make sense? Yeah? Make sense? Okay. So if it does make sense, okay, so let's first do this, but then let me write the y on the other side. Okay, equals y. This is the equation. So what we do in completing squares, after halving and squaring, you add the result on both sides, on the left and on the right, all squared. So let's simplify. Because these two are both squared, we can put them into one block. So 6 divided by 2 is 3, and then we square. And then the other one is y plus 3 squared. So we can take the 3 this side to the left. Okay, we can take the 3 to the left, and we shall have x plus 3 all square minus 3 square equals y. Now in this case, we have got, in this case, let me change the color. In this case, we have got the version that I was talking about. We have completed the square, and from this we can make a conclusion if we are asked to get the turning point. So the turning point, this part, if this part is positive, so the turning point, the x coordinate of the turning point will be negative. So we write negative 3, and then if this part is negative, we take it as it is, like that. So this would be the turning point, but it all comes from completing the squares correctly. Let's try out the second one. Remember, when we are completing squares, we halve the coefficient of x. We halve it. So in this case, the coefficient is 8. So let's halve 8. So 8 divided by 2 is 4, and then we square. So let me write, we have, anyway, to make it clear, I'll write it like this, x squared plus 8x, okay? Now, instead of this negative 3, we put it on the other side of the equal sign. We can say, okay, equals 3, like this. Then let's solve it. Don't worry about the y, of course, it will come back at the end, no worries, okay? Yes, so half the 8, we know that we get 4, so x plus 4 squared, all squared. Does that make sense? Hope it does. Equals 3, but then what you got the other side has to be added. And yeah, so because we halved the 8 to get 4, you square it and add it on both sides. Does that make sense? I hope it does make sense. Alright, so let's simplify. So this is x plus 4 square equals 19. Does this make sense? And then you can now say x plus 4 whole square minus 19 equals y. And then if we are asked to get the turning point would be -4 and -19. Alright, so this is turning points. At the same time, it is completing squares. We shall talk more about turning points when it comes to that, but they are all linked with completing squares, so I decided to talk about it as we continue. Okay, let's try out another one. Here it is. Okay, so what happens when the coefficient, remember, taking you back a bit to this, the coefficient, you are already used to the term coefficient, I'm sure. So the coefficient of x squared in these situations, the beginning examples, is 1. Now what happens when the coefficient of x squared is not 1? It is greater than 1 basically. So that leads us to this example 2. Alright, ready? Let's begin. Okay, so we have this equation. Okay, so I want you to note that the first two terms have a common factor. When we talk about terms, we are talking about this. The first two terms have a common factor. So we are going to separate the c term. The c term, remember the equation, the general form is ax squared plus bx plus c. So when I say c term, we are talking about the constant. Okay, and remember the idea of halving. So let's do this. So this part that I've put in a box, we are going to factorize it because it has a common factor. And that common factor, the 2 and the 6, the common factor is a 2. So we can now say 2 into x squared plus 3x, okay, and then minus 11. Do you see that? I've factorized. We talked about factorization yesterday, and I hope you also have studied factorization at IGCSE level. Alright? Okay. So basically we have this. Now we are going to basically concentrate on this. So we are going to halve the coefficient of x, not forgetting the 2. Alright? So let's do this. So we have a 2 outside. And then I need a bright color. I think I'll stick to yellow because of the background. So 2 into, let's halve. So this will be x plus 3 over 2. Remember, after that we square them just like what we've been doing. Okay, so now here I'll put plus, wait, no, not plus. Okay, just a second. I'm trying to make it simple. Okay, so the 11 can cross over to that side, but after doing this, okay, we add what we got to both sides, like this. Does that make sense? Hope it does. Hope it does. Okay, so let's continue. So now we have 2 into x plus 3 over 2. This is squared. Okay, we can now bring this other 3 over 2 to be a minus. Okay, this is also squared. Remember the 2, this 2 outside the bracket is only multiplying the first one, and then this whole thing here will be subtracting 11 equals 0. Does this make sense? I hope it does make sense, because we have to complete the square for this part and then minus 11. This part, completing square for this first part and then minus 11. So this brings us to this part. Okay, so now you can involve a calculator and now we shall have 2 into x plus 3 over 2 whole square minus, so this is 9 over 4, and putting it on a calculator we can end up with this 9 over 4. Okay, let's work it out. So 9 over 4, negative 9 over 4 minus 11. Alright, so you can check that out to see how we get the 15.5. So let's see, 9 divided by 4 is 2.25, and then 11. So 9 divided by 4, I'm checking also on a calc, so to make sure we get the correct thing. I think this will be 13.25. I think I got that. Let's go step by step. So okay. So here we have 9 over 4, but everything minus 11 equals 0. Hope that makes sense. Hope that makes sense. Let's continue. Okay, you may be wondering how I get 9 over 4. It is 3 squared over 2 squared, this part. And this part you leave it as it is. Let me make it clearer. Okay, we have this. I'll give you a minute to look through and see if it makes sense before I continue. Okay, does it make sense? I hope the questions, I'll find them on the comment section. Okay. Okay, so let's try to continue. And we see how we can get the turning point. So, continuing, we can now remove the brackets. We are going to remove the brackets, and now we have 2 into x plus 3 over 2 whole square minus, now we need an answer here. We get a calculator and we check it out. So 9 divided by 4, 2.25, and then okay, so 9 divided by 9, remember this parenthesis means this parenthesis, this square, I'll use a different color so you can be following. This means, this one means that this 2 will multiply this first part, yes, but also the 9 over 2. So here we get 2, the black is not clear, I'll change the color, 2.25, okay, but this part is still multiplying with the 2, and then minus 11 equals 0. So 2 and this, now we have 2 will still multiply this, and we are removing the brackets, we are removing the parenthesis, so this now gets to 4.5 minus 11 equals 0, and then we now have, I hope you're following, minus 15.5 equals 0. Okay, so you note that if, okay, so basically we have completed the square at this stage. Okay, basically they may be telling us to write in the form. Given this equation, how do we write the form? The form AX, the form that I wrote first. I'll take you back a bit. Remember this form: x plus a into brackets squared plus b. So here, in case this form is true and it is correct if the coefficient of x squared is 1. But if the coefficient of x squared is bigger than 1, then we have this form. Okay, you can see they can say write this quadratic equation in this form and find the value of p, find the value of q, find the value of r. So in this, if you achieve this, you can just pick out p is 2, okay, q is 3 out of 2, you can see that, and then r is 15.5. If this was a plus, then r will be negative 15.5. Does that make sense? So in this case, p is 2, okay, q is 3 out of 2, all right, and then r is 15.5. So basically this is how in AS level they will not ask you complete the square. This is that is very rare in A level, but they'll give you a quadratic equation and they'll ask you to write in a form, and then they'll write something like this, write in the form, and then find p, q, and r. They can use any letters, but this is how you use the idea of completing squares that you got from IGCSE to solve such a question. All right. Okay, so we are going to apply that on the next example. So I'll let it sink in first. I'll give you a minute for you to try out, and then let's see how you can handle it. Okay, now you have tried out, I believe you have tried out some two steps, and let's see whether they were correct. And let's start. So here we have these first two, 4 and 24. You realize that they have a common factor, just like the previous example. So let's factorize first. So 4 into x squared minus 6x, okay, and then plus 19 equals 0. Remember, the question is express this equation in the form. Maybe it is not clear. Let me write it. Ax plus b. These are the A-level questions, the AS level questions in Pure 1 under completing squares. This is how they ask. This is the format they use. So basically, now we have this. I hope you understand my first step. We have factorized the first two terms, 4x squared minus 24x, and we got this. Okay, now we are going to complete the square for this. So remember, halving the coefficient of the coefficient of x rather, beg your pardon. So now we have x minus 3, because halving 6 we get 3, but then it has to be squared. Okay, so in this case, if we took the 19 that side and becomes a negative, okay, we have to add the answer we got here, 3 squared, like this. I hope it makes sense. Does it make sense? Because you add it on both sides. Okay, you add it on both sides. So we have got this. All right, so let's now bring let's make it equal to 0. Let's create a 0. So now we have 4 into x minus 3 and then minus 3. Yeah, you see that? Okay, all of these plus 19 equals 0. Does that make sense? This is squared. I'll erase it and write it clearly. Equals 0. So now this is what we have. I hope it makes sense. And now let's try to simplify just like we did the previous example. We are removing these brackets. So we shall now say 4 into x minus 3 whole square, and then this is 9 and 9 times 4 is 36. This is negative 9 because 3 squared is 9, but there's a minus sign, so negative 9, you can check on the calculator with me. Negative 9 times 4 is negative 36. So now here we have negative 36 plus 19 equals 0. Okay, so now we shall continue. So 4 into x minus 3 minus 17 equals 0. So we have this. Does this make sense up to where we are? Okay, I hope this makes sense. So let's continue simplifying. Remember, we want to write it in this form, so we haven't achieved this form. Remember a note down here, I wrote that let's practice again, this time going to the fully completed form of this. In the first one we were stopping here. Okay, basically at the stage where we are right now is where we stopped in the first one, but sometimes they'll advance it and say write in the form ax plus b into bracket squared plus c. So let's see how we can achieve that. Does that make sense? Okay, I hope it does. So basically we are now going to write, I'll use a different color, hope red works. So we now have 4 into x minus 3. Look at that. Because it is squared, so I'm splitting it up like that. X minus 3, and then minus 17 equals 0. Okay, so and then we can also write this like this, 2 into x minus 3, and then we write another 2 here times 2 into x minus 3. You see how we have splitted. Is splitted correct? We can see how we have broken down the 4, 2 and 2. The 4 creates the 2 and 2. The x minus 3 is still there, and then minus 17 equals 0. Okay, so at this stage we can expand these two, can combine these two, and combining them will lead to something like 2x minus 6 whole square minus 17 equals 0. Okay, so this is what we have, and if we have something like this, we can now do anything we want. Okay, we can find the value of x, the value of y is already 17, negative 17 rather, so y is 17. Y is 17. If we are asked to find y, we take this value as it is. If it is negative, then y is negative 17. Does that make sense? And if we want to, for example, okay, let me write here that to get the turning point from this, we take 2x minus 6 equals 0 and solve this. to get x value. So solving this, x will be 3, okay, and y is already negative 17. So the turning point will be 3, negative 17. If we are asked to find the value of y, the value of x, find the turning point, write in the form ax plus b into whole square plus c, all of these questions have been answered here. So I hope the explanation is clear, and I hope it makes a bit of sense. Let's see, and I would like this to be something you try out. Okay. There is another approach called comparing coefficients. Well, this is one of the workings, and comparing coefficients is another method that can be used, and let's see how it works. Okay, I'll not give this to you as homework to not be fair before I explain, and then you can choose between this method, okay, and this. Remember, here we have not compared any coefficients. I believe you know the meaning of the word coefficients. So we have not compared any coefficients. We have worked it out from first principles and arrived at the answer. Now let's see what it means to compare coefficients. So I'll write here the form that we are interested in. And because this is equal to 0 and this is equal to 0, we can equate them. Okay, let's do that. So now we have 4x squared minus 24x plus 19 equals, and let's expand this immediately. So expanding it will be a squared x squared plus 2axb plus b squared plus c. Does that make sense, class? Hope it does. I just expanded this square bracket, the bracket that has a square, and then plus c. Now here is what we call comparing coefficients. So the coefficient, okay, 4x squared is equal to a squared x squared. So you see that the x squared cancels out and a squared is 4, and that means a will be plus or minus 2. Remember, they can tell you to find a, find b, find c, find the value of a, find the value of b, find the value of c. So in case they ask you to find the value of a, value of b, value of c, just use comparing coefficients. In case they ask you to find the turning point, you use the working I've done in this one that I'm showing you. This is for, mainly it is for turning points in such a question, turning point. And then this, you're finding the values of the coefficients. So let's go to the second one. Negative 24x, we equate it to 2axb. Okay, now simplify this, the x's cancel out. Okay, so if the x's cancel out, we already have the value of a. So we can now bring it in. So negative 24 equals 2 into brackets plus or minus 2, and then b. Okay, so working this out and dividing. So b, of course, you can take 1, you can take positive 2. 2 times 2 is 4. 4 divided negative 24 divided by 4, we get 6. So basically here you can conclude that b is plus or minus 6, because a is plus or minus 2, b is plus or minus 6. So we have got a and b. Now let's look at c. C is 19 on the left equals b squared plus c. Okay, we already have the value of b. So either positive or negative, squaring them will give us the same answer. So this time we don't say plus or minus, so we can just say 36. 6 squared is 36, and simplifying will give us negative 17 as c. Okay, so I hope that makes sense. And now that we have the values of a, b, and c, actually this can also work if we are asked to find the turning point. You can start by comparing, getting the values of a, b, and c, and then we can now bring them in and say a is plus or minus 2. So we just say 2x minus b. B here is a plus 6, so you can say minus plus 6 minus plus 6 is a minus, so we can just write that. And then c is negative 17 equals 0. And then here we can pick up the turning points like I explained in the first slide, because it's the same question. So you just take this, equate it to 0 to find the value of x. So x will be 3, okay, and then y will be negative 17, and then the turning point will be 3, negative 17. So this is an alternative working with this very question. So you can either use this, comparing coefficients, and find the unknowns and then bring them into the form, and also continue to find the turning point. Does that make sense, class? Hope it does. Okay, we're about to finish this. Let's continue to another example here. And this one, they're saying solve by completing square. This is a bit straightforward. I'll let you do this as homework, or as a practice question rather, not homework, practice question. You can use the method that I've been explaining in the very first slide. This one here, you can use this one here to solve this one here. Factorize the first part. You factorize the first part and then you continue to practice. Okay, you can watch the video over and over again and then practice. Here they want us to find the value of x, which you can find. I believe you can find. I'll give you the final answer so you can get it. So x is, you will have something like that. So you work this out on a calculator to get the exact value of x, but I'll let this be your practice question. Okay, and then our second last one is this. Okay, this one is also easy. Okay, I'll give you a hint. You start by removing the denominators. I believe you understand the word denominators. You start by removing the denominators. 2 into x minus 2 plus 3 into x plus 1 all over x plus 1 multiplied by x minus 2 equals 1. So this will be 2x minus 4 plus 3x plus 3 equals x plus 1 multiplied by x minus 2. So here you are continuing correct like terms, so this will be 5x minus, this is minus 4 plus 3, that gives us a minus 1 equals x squared minus 2x plus x minus 2. Okay, so simplifying, I'm just helping you to start, but you'll complete. And then, so this is what we have, and then we can go ahead and combine these to equate it to 0. So combined, we have x squared. Take the left to the right. Remember, it is crossing the equal sign. So we shall have that. And then we have negative 6x minus 1 equals 0. Now this is what we have, and this is what you will work with. So you continue by using completing squares, halve, and then square the result. Halve and square, add it to the left and right. Okay, let me also write this step. If we have this equals 1, halve, I'll write hints, halve the coefficients of x. Okay, halve the coefficient of x, just like we did in the very first slide. All right, I hope that makes sense. Yeah, and I hope that makes sense. And then we have another challenge. You see that? This is also another one. They just want us to find the range. Well, those of you who don't know what range is we can say range could be the value of x. Okay, so where the projectile is something like this. A path taken by anything that is thrown and moves in this trajectory, in this path. So anything, it could be a stone, it could be anything. So this is the range. Okay, so the range is the value of x. You can see it is a horizontal, the x-axis, whatever. So getting they want you to find the value of x. So I'll write here x, and then maximum height is let me redraw it, sorry, something like that. So at this point, so this here is the maximum height, this part here is maximum height. Okay, so maximum height is the value of y. So here they want you to find the value of y. So in part A, if you get the value of x, just substitute in this and then you get the value of y. Okay, and how do we get the value of x? The value of x will be got by solving this equation. Just work it out, simplify it, make sure it is a quadratic, and then solve. You complete the square, or in this case you're free to use completing square or factorizing. Okay, let me try to do this. So part A, they want us to find the range. So if we are finding the range, since it is the x value, it means that the y value is 0. Okay, so to find x implies that y is 0. So automatically y will be 0 if we are finding the range, the horizontal distance. Okay, so that is one basic tip that you need to know. So my pen. So now we have 0 equals 2x minus 3x squared minus 5x over 800. So this is what we have. We can now take this negative part to the other side. So 2x equals 3x squared minus 5x over 800, and simplify all of this, and we shall end up with something like that, equals 3x squared minus 5x, and then simplify to get the value of x. After getting the value of x, this is part A. And part B, use the value of x to, you substitute the value, I'll write here a tip, substitute, sorry for my spellings, but substitute the value of x, into y equals 2x minus 3x squared minus 5x over 800 to get the value of y. All right. Okay, so we've come to the end of today's session. We're continuing with this series of quadratics. This is a first unit 1, pure 1 mathematics. The paper code is 9702, and thank you for taking time and allowing me to be your teacher. This is my channel. It's called Math with Dennis, and I'm Dennis, your teacher. Hope to see you in the next video. Subscribe, like, share, follow me on everywhere on my social media platforms, and also comment. Your comments are really, really valuable. I'll see you in our next video. Bye bye.